All right. Good evening, Algebra 1. All right. Don't ask me why. I'm not even sure why, but for some reason the book starts on number 2. So hopefully you got your book and you're going to be following along. I know certain students like Miss Beatty, you did not get your Algebra 1 book. Hopefully your mom got it squared away today. Um, so let's go ahead and jump in. So exercise 2 says using the numbers 1, 2, 3, 4 only once in the operations plus or multiplication, so addition or multiplication, as many times as you like, write an expression that evaluates to 16. Use the expression and any combination of those symbols as many times as you like to write an expression that evaluates to 816. So I'm going to keep my mouth shut, okay? Because what I want you to do is I want you to do this on your own, all right? You all should be able to come up with a variety of possible answers to where we can all discuss and practice them in the morning time. So exercise 2 I want you to do on your own, okay? Thank you so much. Um, Question number 3. All right, define the rules of a game as follows. So begin by choosing an initial set of symbols, variables, or numeric as a starting set of expressions. Okay. Generate more expressions by placing any previously created expressions in the blanks of the addition operator. Okay. All right. So this is like saying, so you can begin by choosing an initial set of symbols, something like multiplication and subtraction, variable or numeric. So we can say 3, 4, 5, and 6. And that's part of our rules, okay? And then generate more expressions by placing any previously created expressions in the blanks of the addition problem. So like, 4 times 3 plus 5 minus 6, okay? Those would be the expressions, and then you'd be able to come up with an answer. All that's great and dandy. It's not really what we're trying to get into, okay? Tonight we're getting into the algebraic expressions and the distributive property. Okay, so the distributive property is going to be the key in this whole problem. So let's get on moving on to it. Let's go ahead and start looking at number 4 because this is where we start really diving in to the distributive property. So look at number 4. All right. Roma says that collecting like terms could be seen as an application of the distributive property. Is writing x plus x equals 2x an application of the distributive property? Okay, now if you remember, the distributive property states that the number on the outside of a set of parentheses is then multiplied by each number on the inside of the parentheses. So it'd be like a times b plus c. Okay, then you would distribute a to b and a to c in its multiplication. So it'd be a times b plus a times c. Okay, a times b plus a times c. All right, which then would be AB plus AC. All right, so the question then is this the same thing as saying x plus x equals 2x? Can we say that? No, we can't. This is not an effective use of the distributive property. This is not an application of that property. Combining like terms is not the distributive property. It does not follow the same principles. So Roma is not correct in this problem, okay? So continuing on. All right, so number 5. Leela is convinced that a plus b squared equals a squared plus b squared. Do you think she's right? Use a picture to illustrate your reasoning. Okay, it says use a picture, so I'm going to use a picture. All right, so we got a triangle plus a square being squared. Okay, now if you remember, okay, and I'm going to do a little bit of substitution here. If you remember, let's take this and say instead it's a single variable, a, and a is being squared. If you remember that a squared is the same as saying a times a, then we can simply state that this is the same as saying triangle plus square times triangle plus square. Okay, it's a multiplication problem then. Now, in these types of distributive properties, in this type of a distributive problem, things get a little bit messy, okay? So you got to be very careful, okay? So we've got these two pictures. Now, the thing about this type of distributive property is that you take the first term in the first multiplication problem and you distribute it to each term inside the second set of parentheses. Then you multiply the second term by each set inside the second set of parentheses. So you're really doing 4 different steps of multiplication in this problem. Okay, so you got triangle times triangle, which we know should be triangle squared, plus triangle times square, which would be triangle times squared, plus square times triangle, plus square squared. Okay, now we know about like terms. Okay, we know that like terms are terms that look identical to each other and they can be combined. So something like a plus a is the same as saying 2a. A times a is the same as saying a squared. This is when you combine to simplify. Okay, so can we say that a triangle and square and a square and a triangle are the same thing? Yes, we can. We can say that because according to the commutative property of multiplication, the order of the oh my goodness, the factors does not change the product. So this and this are identical to each other. So we can simplify triangle squared plus triangle times square plus square square. So does this look like this? No, it does not. Now I know we're going to have questions, okay? So I want you to come with your questions tomorrow in this lesson. Okay, I know you're going to have questions about this. It's kind of a little messy, okay? But we're going to practice it tomorrow using real numbers so you can see how this works, okay? So just be patient. We'll get there, okay? Like, for example, 6 and 7. I don't want you to use pictures. What I want you to do for 6 and 7 tonight, okay, I want you to actually multiply it out. I want you to multiply it out and simplify. I just want to see if you can use the distributive property effectively to solve these types of problems. Okay? I'm not going to sit there and be mad if you get the questions wrong. I'm going to be very happy if you get them right because that does make things a little easier for us. But I do expect struggles here. Okay? I expect this problem to be extremely difficult. Okay? But I want you to try it. I want you to take the effort. I want you to see what you can come up with. But we'll come back and we'll look at this again in class tomorrow morning, okay? So just be patient. Take it slow, okay? Now, one last thing I want you to take a look at before we move on. See this last statement down here at the bottom? A key belief of arithmetic. The distributive property, if a, b, and c are real numbers, then a times b plus c equals a times b plus a times c, okay? All right. I want you to remember that because that is a very important statement of arithmetic, okay? The distributive property is a major, major important fact that we need to know when it comes to algebra, okay? So you need to get used to practicing the distributive property. All right, so it's a short lesson, all right, but this is what I want us to do. I want us to get a little bit of practice, okay? I want you to practice number 1. It's just asking you to insert parentheses. So that's going to be a homework problem. All right, and let's see. And do number 2 for homework. I'm going to save the rest of these for classwork. Okay? So I just want you to do practice 1 and 2 for me, okay? And we'll go over 2, and we'll go a little bit deeper into the distributive property, okay? There's a lot of stuff here that I want us to be able to practice, and we're going to take the time to do it, okay? So I appreciate you taking the time. All right, guys. Enjoy your evening. Short video tonight. I promise you we're not going to be working too hard on this, okay?